Hey guys, Beijing News all again. So now in this video, I'll be talking about the domain and what exactly is it for a single variable. And I'm going to extend it to a two variable case. Okay, so what did I write over here? So the definition for domain is that it's a real valued function of a real variable x with domain D. Is a rule that assigns a unique real number to each real number x and D. So again, this might sound a bit confusing, but what it's really trying to say here is that, suppose for a function, okay, suppose we have a function that contains x. All this is really trying to say is what values can x take in that function. Can it take all possible values? In other words, can I substitute any number and can it still work? Or is there a limit? Am I cut off at some point? Does x end there? Okay, so let's try and look at an example, okay? Let me just give you a quick example, which I think is very useful. Okay, so let's stick with the most basic one. Okay, so suppose you have a function, okay? A function which is described by x squared, okay? So now we look at this and we just think to ourselves, what values can x take here, okay? X can actually take all possible values. If x equals 1, the function x equals 1. If x equals 2, the function x equals 4. In other words, you can substitute any number and it doesn't cut off. At this point, we say that x belongs to all real numbers. Okay, so when we say the word real, what we really mean real, in other words, this notation, we mean that it can take, for example, x equals a quarter and still provide a solution. Quarter squared is 1/16. X can be a square root, root 2. The function is square root is 2, and so on. So technically, this means that the domain D states that x can belong to all real numbers in R. In other words, we say x belongs, this notation is kind of E/epsilon looking thing, means belongs. This means x belongs to all real numbers, okay? This implies that x can take values from -infinity to +infinity. This is what the state means, R, okay? So this is a simple example. However, there may be times where you don't actually have that, okay? By the way, the solution for the function is actually called the range, okay? So we'll go back to that again afterwards. Now suppose I have another example. Suppose fx equals 1/x plus 3. So notice that for this value here, this means that the domain in this case cannot be, this bottom fraction cannot be 0. You know that, right? So this implies that x plus 3 at the bottom cannot equal 0. Why? Because 1/0 is undefined. So, if we were to rearrange this, then this would mean that x cannot equal -3. So actually, the domain here implies that x can be x can be any number but -3. So then what we say that the domain for this case is that x cannot equal -3, or x belongs to -infinity to -3 and is unified between -3 and +infinity. This U means it takes all values between -infinity to -3, but just before -3 and after -3 to infinity. So it does not take the exact point -3. This means like -2.999. This means -3.0001 and so on. This U means it's unified from this to this, and there's a gap. The gap is -3. So this is quite clear. So this applies for something like a fraction. How about if we had a square root, a third function? Okay. The next example would be this. Suppose the function now was the square root of 2x plus 4. Okay. Again, this is a bit different because now this implies for square root, what do we know about square roots? The domain of it. The inside cannot be negative. In other words, it has to be 0 or positive. So this implies that the inside, 2x plus 4, has to be greater or equal than 0. Hence, we can calculate our domain from this. So if we solve this, subtract -4 and divide 2, we should get x is greater than or equal than 2. You see? Oops, not 2, -2, sorry. x is greater than or equal than -2. So this is actually our domain. So our domain for this case is this. Our domain is defined by x greater than -2. In other words, x can take values between -2 to positive infinity. Great. So this is pretty much the domain defined. Hope this helps. Now, let's consider a two variable example. Now, this will be slightly more difficult, okay? Let me just quickly open this up. Okay, so suppose I have a function now, xy. So this is a two variable case. And this is defined by the following, okay? We have a root here. So we're going to have 1 minus log x at the bottom and square root of 9 minus x squared minus y squared. Okay, so the question here is to actually state what is the domain of x and the domain of y. So again, so in this case, we look at the top and the bottom line. Let's try and understand it. So on the top line, we have, on the bottom line, we start with that. We know that as a fraction, this cannot equal 0. So this means that 1 minus log x cannot equal 0. Okay, so let's solve this. So plus and log x across, we're going to have log x doesn't equal 1, and then taking exponentials, x doesn't equal e to power 1. In other words, just e. So we know at one given point, x cannot equal e. Okay, so this is just one condition. So let's look at another one. Let's look at the top line now. Okay. So what else can we say about this part here? We know that the inside of a root cannot be has to be greater than or equal than 0. Cannot be negative. So we know that 9 minus x squared minus y squared has to be greater than or equal than 0. So we can plus these two across. So we're gonna have x squared plus 9 squared less than or equal than 9. So this is more of a circle equation, isn't it? But at this stage, I would say leave at this point because you can't really solve for y properly or x. Okay, so really the domain in this case for x and y would be this if this is true, and this is another one's true. Also know that for the log x, for the log of x, actually no, this is fine. This is fine. This would actually be the domain, in fact. And of course, yes, the final thing would be log x. For log x in particular, the inside of the log has to be, the x inside has to be greater than 0. Because if it was less than, well, it doesn't equal 0 firstly. If it was less than 0, then we're going to have imaginary roots. So we're not interested in imaginary. We just want real parts, the domain of the real part. Remember in the definition where I state we're interested in the real valued integers or real valued numbers. So finally, if we're going to define this full function, we're going to say that D, the domain in x and y, so this is a good way to write this, belongs to R squared, so in 2D space. And now this tells us, so from here we can say that we just combine everything. We say that x is greater than 0 and x doesn't equal e and x squared plus y squared is less than or equal than 9. And this would be our domain. So guys, hope this helps, and if you need any other questions or further examples, please let me know below. Thanks.